previous group of videos, we reviewed the general probability rules. Probably not as big a factor on the AP exam as this chapter. In Chapter 6, we're going to talk about random variables and probability. What's important as you go through this video with me is the difference between how you would handle a multiple choice question and a free response question. You know, in a multiple choice question, just grab your calculator and use the formulas I show you. But if it's a free response question, we'll talk in more detail about what all you should write if it's about a random variable. First of all, in Chapter 6, you learned how to calculate the mean, variance, and standard deviation of a random variable. Let x equal a discrete random variable with possible outcomes x1, x2, x3, and so on. The expected value formula is p1 times x1 plus p2 times x2 plus p3 times x3 until you're done. The formula for the variance is p1 times x1 minus the expected value squared plus p2 times x2 minus the expected value squared plus, until you just keep going until you're done. And then the standard deviation of a random variable is equal to the square root of the variance that you just calculated. So let's see how these three formulas work out in an example. Steve Jeep Tours is offering a discount to customers. He gives each customer a pair of dice. If the customer rolls a sum of 7, there's a $5 discount. If the customer rolls a sum of 2 or 12, there's a $10 discount. Otherwise, there's no discount. Calculate the average discount per customer, the variance, and the standard deviation. If this were a free response question, you would want to define your random variable, right? X equals the amount of discount. Or you could say let D equal amount of discount. And then you write all of the different values that that variable can take on, 0, 5, or 10 in this case. And then you make a table called a probability distribution table. X is one row and probability is the other row. So I wrote 0, 5, and 10 across the X row. Now I've got to determine the probability of getting a $0 discount, a $5 discount, and a $10 discount. Now, if you roll a sum of 7, you get a $5 discount. Well, this table helps me to see that there are 6 different ways to roll a 7. So then this is a 6 out of 36 or 1 out of 6 chance of getting a discount of $5. 1 out of 6 chance, okay? If the roll a sum of 2 or a 12, you get a big $10 discount. Well, I see that there are 2 out of 36 ways or 1 out of 18 ways of getting a $10 discount. Okay? Now, the easiest way to find the probability of getting no discount is to remember that these probabilities must add up to 1. So then let's see, 1/6 plus 1/18, that's 3/18 plus 1/18, that's 4/18, which is 2/9. So if I take 1 minus 2/9, I should put a 7/9 there. Remember that the sum must equal 1. Now, I'm going to erase all this. That was just me showing you how I was calculating those probabilities. Very frequently, the table that you see is something that's given or at least partially given. Okay? So I'm just going to check. Does 7/9, let's see. Does 7/9 on my calculator plus 1/6 plus 1/18. Let's see, I'm almost done. Equal 1. Yes, it does. So I'm comfortable with my table. So now I can say that the expected value of x is equal to the first probability times the discount plus the second probability times 5 plus the third probability times 10. So I grab my calculator, and let's see, that's 1/6 times 5 plus 1/18 times 10. Okay, I get $1.39. So the average discount from customer to customer is $1.39. It's like giving everybody a $1.39 discount. So now the variance of x is equal to, this is horrible, 7/9 times 0 minus $1.39 squared plus 1/6 times 5 minus $1.39 squared plus 1/18 times 10 minus $1.39 squared. So unfortunately we got to type all that in. So let's see. 7/9 times 0 minus $1.39 squared plus 1/6 times 5 minus $1.39 squared plus 10 minus, plus 1/18 times 10 minus $1.39 squared. Okay, I see 7.793 is the variance. So the standard deviation is simply equal to the square root of 7.793. And so then, doing that on my calculator, I get a standard deviation of $2.79. So make sure you can do that. I think you've seen a problem or two similar to that on the 2012 exam. Next, in Chapter 6, we learned how to do transformations of a random variable, where we can add or subtract a constant to a random variable or multiply a random variable by a number. So we have 4 formulas in 2 groups. The expected value of x plus or minus a constant is equal to the expected value of x plus or minus that constant. The standard deviation of x plus or minus a constant is equal to the standard deviation of x. In other words, when you add or subtract a constant, it has no effect on the spread. We talked about that a lot back in Chapter 6. The expected value of a times x is equal to a times the expected value of x. The standard deviation of a times x is equal to a times the standard deviation of x. So like, for example, what if we were given that the expected value of some random variable of x was 2 and the standard deviation of x was given to be 3? I don't know, I'm just making this up. And somebody said, what is the expected value of x plus 5? Well, that would be equal to the expected value of x plus 5, so that would be 7. The standard deviation of x plus 5 would equal the standard deviation of just x, so the answer would still be 3. See, they're expecting you to add 5 and call the new standard deviation 8. The expected value of 2x would equal 2 times the expected value of x, so that would be 2 times 2 is 4. The standard deviation of 2x equals 2 times the standard deviation of x, which would equal 2 times 3, which would be 6. And then you've seen something like this. What if they say, what is the expected value of 2x plus 3? Well, that would be equal to the expected value of 2x plus 3, and that would be 2 times the expected value plus 3, and the answer would be 7. And then if they say the standard deviation of 2x plus 3, according to these formulas, that would be equal to the standard deviation of 2x, which is 4. See, they would expect you to incorrectly say that that's equal to the standard deviation of 2x plus 3, and next thing you're calling the answer 7. Okay, moving on to word problems. Steve's Jeep Tours has an average of 6 customers per day, so E of x equals 6, if x is defined as the number of customers per day, with a standard deviation of 1.2. So the standard deviation of x is 1.2. If Steve charges $100 per customer but has to pay $85 for fuel per trip, what is the average revenue he makes per day with what standard deviation? I'm being asked to calculate the expected value of 100 times x minus 85 and the standard deviation of 100 times x minus 85. So the expected value would be equal to 100 times the expected value of x minus 85. So would that be 100 times 6 minus 85? 600 minus 85 would be $515 per day, or per trip, I should say. The standard deviation is equal to 100 times the standard deviation of x minus 85? No, that's wrong. Not the minus 85. Just 100 times the standard deviation of x, sorry. And so that would be equal to 100 times 1.2. And so then that would be $120 standard deviation, where they were expecting you to subtract 85 and get the answer wrong. So let's remember that, not minus 85. Combining random variables. Suppose that you already know the mean and standard deviation of a random variable x and the mean and standard deviation of a random variable y. Well, then if you combine them, the expected value of x plus or minus y is equal to adding or subtracting their expected values. But remember, this is the asterisk from when we were learning chapter 6. The standard deviation of x plus or minus y is equal to the square root of the variance of x plus the variance of y. So let's see how these formulas work out. A major university has 2 campuses, their main campus and their downtown campus. The average tuition at the main campus is $732.50 with a standard deviation of 103. The average tuition downtown is $825 with a standard deviation of 126.50. One student is randomly chosen from each campus. What are the mean and standard deviation of the combined tuitions? So they're asking me to find the expected value of Maine plus downtown and the standard deviation of Maine plus downtown. So the expected value of Maine plus downtown is the expected value of Maine plus the expected value of downtown, which is just $732.50 plus $825. So if you combine the tuitions of one student from each campus, $732.50 plus $825 is merely $1557.50. $1557.50. Now, the standard deviation. I'm going to make some mistakes on purpose. Students do this all the time. The standard deviation of Maine plus downtown is equal to the standard deviation of Maine plus the standard deviation of downtown. And so they say that the answer is 103 plus 126.50. And so they leave swearing that the answer is 229.50. Just thinking that they did everything right, they just needed to add those two numbers together. That is incorrect. What do we have to do to find that true standard deviation of m plus d? Well, let's see. the true standard deviation of m plus d is equal to the square root of the variance of Main plus the variance of downtown. So that's actually equal to the square root of 103 squared plus 12650 squared. So remember, if 103 is a standard deviation, 103 squared had been the variance. So if I take 103 squared plus 12650 squared and take the square root of that, I get 16313. And you see, if this were just a part of a bigger question, you would have your incorrect standard deviation if you did it the way where you just add the 103 and 12650. And then you move on and you do something with that incorrect standard deviation. You'll only lose points for the incorrect calculation on the standard deviation, but you may get full credit on the later parts. What are the mean and standard deviation of the difference in the tuitions? The expected value of Main minus downtown and the standard deviation of Main minus downtown. Well, this one is obviously just 732.50 minus 825. No big thing there. But this one here, I wanted you to highlight that this is equal to the square root of the variance of Main plus the variance of downtown. No matter what, whether you're adding or subtracting two random variables, the standard deviation is always the square root of the variance plus the variance. So that means that the answer is still that 16313. Try not to forget that. If two main campus students are randomly selected, what are the mean and standard deviation of the combined tuitions? This part C is given on purpose to remind you of a very common mistake. If two main campus students are randomly selected, are they asking me to find the expected value of student 1 plus student 2? Or am I asked to be finding the expected value of two main campus students? Well, it turns out it doesn't matter how you think of the expected value, because that's just going to be 732.50 plus 732.50 is equal to the correct answer. But if you do 2 times 732.50, you'll be correct both ways. Okay, but what were they actually asking you to do if two main campus students are randomly selected? You were actually being asked to calculate the expected value of x1 plus x2. Here's where the real error can occur. The standard deviation of x1 plus x2, or the standard deviation of 2x. Well, you know, in algebra, x plus x is equal to 2x. Yeah, that's true in algebra. But watch what happens in terms of the standard deviation. This is equal to the square root of 103 squared plus 103 squared. This is equal to 2 times 103, which is 206. Well, let's see what the other answer turns out to be. 103 squared plus another 103 squared, and the square root of that is 145.66. So notice that the standard deviation of x plus x is not equal to the standard deviation of 2x. So it's really important that you understand in this problem, this is the correct answer. We were looking for the standard deviation of student 1 plus student 2. What does the standard deviation of 2x mean? It's like somebody was saying double the tuition. So if the question said, hey, double the tuition, what's the new standard deviation? Then 206 would be correct. But this wasn't about doubling the tuition. It was about combining two students' tuition. What is the new standard deviation? So hopefully you remember that as well from Chapter 6. Last slide, free response type questions. If two random variables both have normal distributions, then if you combine those two random variables, you will get a normal distribution. So let's take a look at two examples. If these were multiple choice questions, you'd be able to just answer these with normal CDF. But if they're free response, we need to talk about what you would have to do here. The distribution of adult male heights is normal with a mean of 70 inches and a standard deviation of 2 inches. The distribution of female heights is normal with a mean of 68 and a standard deviation of 1.5. Randomly select a male and a female. What is the probability that their combined heights will exceed 140? What is the probability that a male plus a female will exceed 140? Well, in a normal distribution of combining two different normal distributions, the expected male plus female would be 70 plus 68, 138 inches. So I'm going to draw a normal distribution with a mean of 138 inches combined. So now 140 is over here and shade to the right. So don't forget, whenever you're doing a normal distribution problem in free response, you must draw a normal distribution with shading. Okay, now, I know that you're going to answer this question with normal CDF, and you're going to put 140 as the left bound, you're going to put a big number as the right bound, and then you're going to put that 138 as the mean, and then you got to put that standard deviation in. Well, what's a student going to do that's a mistake? They're going to say, oh, I combined the males plus the females, so if I simply add 2 plus 1.5, that's 3.5. Maybe that's the number that I should put right there. That is wrong. The standard deviation of male plus female is equal to the square root of the variance, 2 squared for the males, plus the variance for the females, 1.5 squared. So let's see, that's 4 plus 1.5 squared, and then take the square root of that. So I just got 2.5 is the new standard deviation. So now put 2.5 there. And so now you want to grab your calculator and you want to do that whole normal CDF thing. So let's see, I'm trying to get to that phase on my calculator right now. So let's see, menu, statistics, distributions, normal CDF. We want to put 140 as the lower bound, some big number as the upper bound. The mean is 138, and the standard deviation is 2.5. And so the calculator tells me that this shaded area is roughly 0.21. Remember, if this is a multiple choice question, that 0.21 is all you're looking for. You're not going to get the right answer if this standard deviation is wrong. That's the whole point of this problem. Did you calculate that standard deviation and that mean correctly? Now you must write a complete sentence if this is free response. Don't just make a calculation without writing a complete sentence. There's approximately a 21% chance that the sum of their combined heights will exceed 140 inches. Now, don't forget one other thing. When you're doing a free response question about a normal distribution, even though you didn't use it at all, you must include the z-score for this problem. And if I take 140 minus 138 divided by 2.5, I will get that z-score that needs to be shown as part of my work. Okay, so if we move on to our last problem in this video, randomly select two males. What is the probability that their combined heights is less than 135? What is the probability that male 1 plus male 2 is, less than 135 inches? Okay, so I've got to calculate the expected value of male 1 plus male 2, which is easy enough. That's 70 plus 70. And then I've got to calculate the standard deviation of male 1 plus male 2. And the only way to correctly do that is the variance of male 1 plus the variance of male 2. You could be so wrong if you just say 2 plus 2, standard deviation plus standard deviation. So then that's the square root of 8, and that's 2.83-ish. So in the interest of time, that would be normal CDF, little number, comma 135, comma 140, comma 2.83. And so you enter that in and you'll have your correct answer. The big thing is, did you calculate the mean of m plus m, and did you calculate the standard deviation of m plus m correctly? And so you would have, if you know that the square root of the variance of m plus the variance of m, which is the square root of 2 squared plus 2 squared. I certainly hope this video helps review random variables. You've already seen it on a Release 2012 exam, so I'm sure you'll be seeing this again.